There is a mountain in the middle of the Atlantic Ocean that most of the world has never thought about twice. It rises out of a small Spanish island higher than anything else on Spanish soil, higher than any peak in Western Europe west of the Alps. And for over a century it has done nothing but sit there, quiet, snow-capped in winter, sold on postcards, climbed by tourists in cable cars who take a photograph and go back down to the beach. But in the early months of 2026, something underneath that mountain began to change. Not on the surface, not in a way any tourist walking through the black volcanic sand of Teide National Park would notice. The change was happening kilometers below, in the dark, in the rock, in places no camera has ever reached. And the people whose entire job is to listen to that mountain 24 hours a day, on more than 100 instruments buried across the island, started seeing numbers they had not seen in years. Numbers that made them stop, lean forward, and start asking a question nobody wants to ask about a volcano that sits above 250,000 residents and millions of tourists a year. Is Teide waking up? This is the story of Mount Teide and of the seismic swarms that have shaken the ground beneath Tenerife through 2026, of the scientists who have spent months trying to read the language of a mountain that refuses to speak clearly, and of the uncomfortable truth sitting underneath all of it, that nobody, not the best seismologist in Spain, not the most advanced satellite in orbit, can tell you with certainty what a volcano is going to do next. Teide is not just any volcano. It is the third largest volcanic structure on Earth, measured from its base, rising nearly 7,500 meters from the floor of the Atlantic if you count what is hidden underwater, with only Mauna Loa and Mauna Kea in Hawaii standing taller from base to summit. Above sea level, it reaches 3,718 meters, making it the highest point in all of Spain, higher than anything on the Iberian mainland, higher than anything in Portugal, higher than every peak in France outside the Alps themselves. It sits inside Teide National Park, a UNESCO World Heritage Site, a landscape so alien that European Space Agency scientists have used its lava fields to test equipment destined for Mars. It is a stratovolcano, the same violent, explosive category as Vesuvius, as Pinatubo, as Fuji, built in layers of hardened lava and ash from tens of thousands of years of eruptions, the most recent visible activity coming from vents on its flanks in the early 20th century. For over 100 years, it has been officially classified as dormant, not dead, dormant, the geological word for a volcano that is not currently erupting, but has not been ruled extinct either. And dormant volcanoes, as every volcanologist will tell you, are the ones you watch the closest, because dormant simply means the countdown has not visibly started yet. To understand why a handful of scientists in the Canary Islands spent the first months of 2026 staring at seismographs instead of sleeping, you have to understand what kind of place Tenerife actually is. The Canary Islands are not a random scatter of land in the Atlantic. They are the visible tips of an enormous volcanic hotspot, a place where a plume of unusually hot material rises from deep within the Earth's mantle and slowly melts its way toward the surface, the same basic mechanism that built Hawaii on the opposite side of the planet. Every island in the chain, from Lanzarote in the east to El Hierro in the west, was built entirely by volcanic eruption, layer upon layer of cooled lava stacked over millions of years until the peaks broke the surface of the ocean. Tenerife itself is essentially one enormous volcanic edifice, with Teide sitting at its structural and historical center, a mountain built inside the collapsed remnant of an even older, larger volcano whose flanks gave way in a catastrophic landslide roughly 170,000 years ago, an event so large it sent debris scattering across the seafloor for kilometers in every direction. Teide, in other words, is not simply a mountain that happens to be a volcano. It is the current active chapter of a process that has been reshaping this island for millions of years, and will, geologically speaking, continue reshaping it long after every person reading this account is gone. The last time lava actually reached the surface on Tenerife was in 1909, when the vent known as El Chinero, on Teide's northwestern flank rather than its summit, opened and produced a modest eruption that lasted roughly 10 days. Before that, the 19th century saw several other eruptions scattered across the island's flanks. Since 1909, Teide itself has remained visibly quiet, its summit crater emitting nothing more dramatic than wisps of steam and sulfur smell near a handful of fumaroles close to the peak, popular enough with hikers that a cable car now carries roughly 1 million visitors a year to within a short walk of the summit. For over a century, that has been the entire visible relationship between Teide and the outside world. A quiet giant, a tourist attraction, a UNESCO site, a mountain people photograph rather than fear. But dormant is not the same word as extinct, and nowhere is that distinction taken more seriously than inside the offices of the Instituto Geográfico Nacional and in Vulcan, the two institutions that have spent decades building one of the densest volcanic monitoring networks anywhere on the planet, specifically because they know exactly what kind of mountain they are dealing with. Long before 2026, both organizations had already logged a slow accumulation of small warning signs stretching back a full decade, isolated seismic swarms in 2016, again in 2019, twice through 2022, once more in November of 2024, and again in August of 2025. Individually, each of those episodes produced a cluster of tremors too small to be felt by anyone on the surface, and faded without consequence. But scientists do not read individual episodes in isolation. They read trends. And the trend line running from 2016 through the start of 2026 was not flat, it was climbing. The story of what became the defining seismic year for Teide begins, in the official record, in February of 2026. Though the truth is, the ground beneath Tenerife had already been restless for years before that. Scientists at Spain's Instituto Geográfico Nacional, the national body responsible for tracking every tremor across the country, had already logged seismic swarms beneath Teide in 2016 and 2019, twice in 2022, again in November of 2024, and once more in August of 2025. Each of those episodes came and went. Each one produced small tremors too weak to be felt by anyone standing on the surface. Each one was followed by silence, and each one was filed away as part of what volcanologists call background unrest, the low hum of a system that is alive but not necessarily preparing for anything. But in February 2026, the pattern shifted. What had been isolated episodes, separated by months or years, began arriving in rapid succession, closer together, and in places seismologists had not expected. It started quietly, the way these things almost always do. On the 11th of February, the Instituto Geográfico Nacional recorded an unusual burst of microseismic activity beneath the volcano, a series of tremors occurring between 4 and 7 in the morning, too faint for any resident of Tenerife to notice as they slept. At the same time, a separate observatory on the island, in Vulcan, the Volcanology Institute of the Canary Islands, picked up something more specific. A series of hybrid seismic events, tremors that carry the signature of both regular rock fracturing and the movement of fluid or gas beneath the surface, clustered 9 to 12 kilometers deep, positioned southwest of Pico Viejo, the twin peak that sits beside Teide itself. Dozens to hundreds of small magnitude events packed into a matter of hours. To the untrained eye, these are just numbers on a seismograph. To a volcanologist, hybrid events at that depth and that location are one of the signatures associated with the earliest stages of magma movement, fluid pushing its way through rock far below the surface, testing pathways it may or may not ever use. 5 days later, on the 16th of February, the swarm returned, and this time it was not subtle. Beginning in the late afternoon and building through the night into the early hours of the 17th, the western sector of Las Cañadas, the vast volcanic crater that surrounds Teide, lit up on every monitoring screen the IGN had. By the time analysts finished counting, they had identified 755 separate hybrid earthquakes tied to that single episode. And even that number came with a caveat scientists rarely attach so bluntly to public statements that the real total could be higher, because many of the signals were so faint and so tangled together that distinguishing one event from the next at the edge of the instrument's sensitivity was, in their own words, extremely difficult. 755 confirmed tremors in under 24 hours, in a place where a normal week might produce none at all. 3 days after that swarm settled on the 19th of February, the mountain did something it had, according to the scientists monitoring it, never done before. A 90-minute-long low-intensity seismic tremor rolled beneath the volcano, a single sustained signal rather than a burst of discrete quakes, a pattern the head of the IGN in the Canary Islands, Itahisa Dominguez, described publicly as something never recorded before in Tenerife. Not never recorded before that month, not never recorded before that year, never recorded before in the full history of instrumented monitoring on the island. When a scientist who has spent a career reading these instruments says a signal is unprecedented, that word is not chosen lightly, and it was not chosen lightly here. The following day, the 20th of February, brought the number that would end up in headlines across Spain and beyond. In a single 24-hour window, monitoring stations logged more than 1,400 separate tremors beneath the island, 1,400 in a day. Spanish broadcaster RTVC quoted seismologists confirming that all of these events were located west of Las Cañadas, roughly 10 kilometers below the surface, consistent with what had already been building since the start of the year, and confirming that by that point the island had experienced 3 distinct seismic swarms in the space of little more than a week, the most recent of which, they noted, had already tapered off entirely by the time they spoke, small, weak signals fading out on their own. It is a strange, almost contradictory thing to sit with. 1,400 tremors in a single day, and in the same breath, scientists describing the very swarm that produced them as having ended, faded, calmed. That contradiction, that coexistence of alarming numbers and reassuring context, would define almost every update to come. Because here is what the data was not showing, and this matters as much as everything it was. Alongside the seismic count, IGN and InVulcan track a handful of other signals that, together, form the real picture of whether a volcano is preparing to erupt or simply shifting in its sleep. Ground deformation, measured by GPS stations, bolted to bedrock across the island, tracking whether the surface of Tenerife is physically rising or swelling as magma pushes upward beneath it. Gas emissions, principally carbon dioxide and sulfur dioxide, seeping from fumaroles near the summit, tracked because a genuine magmatic intrusion typically pushes gas ahead of it long before rock ever breaks the surface. In-depth migration, whether the earthquakes over time are climbing shallower, moving from the 10 to 15 kilometer range where this activity has consistently sat, up toward the 2 or 3 kilometer range, that would suggest magma is actually approaching the surface rather than churning far beneath it. Through the entirety of the February swarms, none of the three showed the kind of acceleration that would flip Tenerife's official alert status. It remained at green, the lowest tier, the same level it has held for years. It is worth pausing here to understand exactly what these instruments are actually capable of, because the density of Tenerife's monitoring network is, in itself, one of the more remarkable parts of the story. Seismometers buried across the island can detect tremors so faint that a person standing directly above them would feel absolutely nothing, registering movements measured in fractions of a millimeter deep underground. GPS receivers bolted into solid bedrock track the physical position of the island's surface with a precision fine enough to catch uplift measured in single millimeters per year, which is how 3 years of gradual swelling can be confidently reported as 2 centimeters rather than dismissed as instrument noise. Gas analyzers positioned near summit fumaroles continuously sample the ratio of different gases escaping the mountain, because magma rising toward the surface changes that chemical signature in specific, well-documented ways long before any visible activity would ever occur. Layered together, these 3 data streams, seismicity, deformation, and gas chemistry, form what volcanologists call a multi-parameter monitoring system. And the entire philosophy behind it is that no single signal, however dramatic it looks in isolation, should ever be read alone. A swarm of tremors without accompanying uplift or gas change points toward rock simply adjusting under existing pressure. A swarm of tremors combined with accelerating uplift and shifting gas ratios points toward something else entirely, magma physically forcing new pathways through the crust. Throughout 2026, Tenerife has consistently shown the first pattern, not the second, and that distinction is precisely why alert levels have not moved even as tremor counts climbed into the thousands. That distinction matters because it is the difference between 2 very different kinds of stories. The story of a mountain adjusting internal stress the way a building settles on its foundation after decades of standing, and the story of a mountain actively preparing to erupt. Scientists have seen both patterns before, on Teide and on volcanoes around the world, and they have learned, sometimes at great cost, not to confuse one for the other. In 2011, a similar swarm of seismic activity struck the neighboring island of El Hierro, further west in the same volcanic chain, and in that case, the pattern did continue to escalate, culminating in an actual submarine eruption off the island's southern coast that lasted nearly 5 months, producing a visible plume of discolored water and floating volcanic rock that made international news. That event remains, for scientists across the Canary Islands, the most recent proof that these systems are capable of moving from background unrest to genuine eruption. And it is part of why nobody monitoring Teide in 2026 has been willing to dismiss what they are seeing outright, even while insisting, correctly, that the current data does not yet point in that direction. And yet Idahiza Dominguez, the man whose entire job is reading these instruments and briefing the public honestly, did not simply wave the concern away. In an interview conducted after the February swarms had settled, he laid out a picture more nuanced than either panic or dismissal. He pointed to a broader accumulation of signals that stretched back nearly a decade. Not just this year's tremors, but the repeated small earthquake swarms recorded since 2016, a documented increase in gas emissions at Teide's summit fumaroles over that same period, and most significantly, approximately 2 centimeters of measurable ground uplift recorded across the last 3 years. 2 centimeters sounds small when you say it out loud. 2 centimeters is the width of a fingertip. But across an entire volcanic edifice the size of Teide, sustained uplift of that magnitude over that time frame is not nothing. It is a physical record of pressure building somewhere beneath the rock, whether from magma, from heated fluid, or from processes still being debated among the scientists who study it. Dominguez's conclusion was neither an alarm bell nor a dismissal. Tenerife, he said plainly, is a volcanically active island. Whether that decade-long accumulation of small signals will ever culminate in an eruption, he said, is not something science can currently answer. Statistically, he noted, the likelihood remains low in the short and medium term. But he added something that stayed with everyone who heard it, that the longer a volcanic system remains quiet, the more likely it eventually becomes that something will happen. Every volcano, he explained, behaves differently. some producing decades of exactly this kind of low-level signal with no eruption ever following, Teide's own crust thin enough, and its magma reservoirs deep enough, that any buildup toward eruption could unfold not over weeks or months, but over years, even decades. That single sentence, that the longer a system stays quiet, the more likely something eventually happens, sits at the exact center of why this story matters. Because it is not a prediction. It is a statement about probability compounding across time, the kind of statement a scientist makes when they refuse to lie to you in either direction. It does not say Teide will erupt. It does not say Teide will not. It says the clock, in some sense, is always running, and every year of accumulated small signals adds another data point to a picture nobody alive today has the complete version of, because the last confirmed eruption from Teide's own summit area occurred in 1909, from an event called El Chiniero on its flank, more than a century before any of these instruments existed to record what came before it. As February gave way to spring, the swarms continued to appear and fade in cycles, a rhythm that itself is characteristic of restless but non-eruptive volcanic systems worldwide. On the 26th of February, a magnitude 4 earthquake rattled tourists across Tenerife, strong enough this time to actually be felt on the surface, strong enough to briefly dominate headlines, suggesting the volcano itself had finally moved. But the deeper data told a different, almost stranger story. That particular quake had not come from Teide at all. It originated from Enmedio, a submarine volcano roughly 500 meters tall, sitting on the seafloor roughly halfway between Tenerife and the neighboring island of Gran Canaria, a structure that had itself produced a magnitude 5 earthquake back in 1989 and appeared to simply be repeating a pattern of its own, unrelated to the swarms building beneath Teide's own summit. It was a reminder that the Canary Islands sit atop an entire volcanic archipelago, layered with multiple independent systems, and that reading any single signal in isolation, without the full context the professionals have spent years building, is exactly how public panic outruns public fact. Through late February and into March, the character of the tremors beneath Teide itself began to sharpen in one specific way that volcanologists watching closely noted without alarm but with clear interest. The isolated weak seismic events, roughly 10 kilometers beneath the surface, continued clustering in the same western sector of Las Cañadas, near the towns of Villaflor de Chasna and Guia de Isora, with occasional events reaching down as deep as 12, even 15 kilometers. These depths are significant because they place the activity well below what is known as the brittle ductile transition, the boundary in the crust below which rock behaves less like something that fractures and more like something that flows. Activity at that depth is generally read as deep magmatic or fluid movement rather than anything approaching an imminent surface event, essentially the geological equivalent of pressure shifting in the foundation of a building many floors below the one anyone actually lives in. By late spring, monitoring bulletins were describing the situation in consistent language, an active but not imminently dangerous system. Thousands of small, mostly unfelt tremors accumulated across the year, a swelling body of long-term signals that scientists themselves openly acknowledge they cannot fully interpret, and a public messaging strategy built around one central, repeated fact that Tenerife sits beneath one of the densest volcanic monitoring networks anywhere in Europe. Over 100 separate monitoring stations, operated jointly by IGN and Vulcan and other institutions, blanket the island, tracking seismicity, ground deformation, and gas chemistry in near real time, feeding directly into an alert system designed specifically so that any genuine acceleration toward eruption would be caught not in days, but, officials have stated, with enough lead time for evacuation and response to be organized well in advance. Rosa Davila, president of the Tenerife Cabildo, the island's governing council, addressed the public directly during the height of the February swarms, stating plainly that the island is more prepared than ever for any volcanic scenario, pointing to continuous monitoring, established coordination between local authorities and national scientific bodies, and emergency protocols that have existed and been refined for years, specifically because officials have long understood that living beside an active stratovolcano requires permanent readiness, not occasional attention. It is also worth understanding what an eruption on Tenerife would actually mean in practical terms, because the stakes here are not abstract. Tenerife is the most populated island in the Canary archipelago, home to roughly 1 million permanent residents, and one of the most visited islands in the world, drawing close to 6 million tourists a year to its beaches, its hotels, and its national park. Unlike a remote volcanic island with no infrastructure to protect, an eruption here, even a moderate one, would unfold in proximity to airports, highways, resort towns, and a dense coastal population, which is precisely why the density of the monitoring network and the seriousness with which every swarm is treated cannot be overstated. Local authorities have spent years building specific evacuation protocols tied directly to the same alert tier system the IGN uses for its seismic bulletins, protocols that were quietly tested and refined further during the El Hierro eruption in 2011 and have continued to be updated since. Rosa Davala's public reassurance during the height of the February swarms was not simply a soothing soundbite. It was a reference to a genuine, rehearsed system of coordination between the Cabildo, national scientific bodies, and emergency services, one designed on the explicit assumption that if Teide ever does begin a genuine escalation toward eruption, the earliest warning will not come from a sudden explosion. It will come from exactly the kind of data currently being gathered, tracked, and published in real time. That is the tension sitting at the heart of the Teide story, and it is worth sitting with honestly, rather than resolving it into a simple headline in either direction. On one side, every individual signal, taken alone, remains within the range scientists consider normal background activity for an active volcanic island, precisely the kind of low-level unrest Teide has produced in cycles since at least 2016, arguably for far longer than any instrument has been recording. On the other side, the cumulative weight of what has been measured, thousands of tremors compressed into a matter of months, an unprecedented 90-minute tremor unlike anything in the recorded history of the island, measurable ground uplift sustained over 3 years, and rising gas emissions tracked over nearly a decade, forms a pattern that even the scientists closest to it describe not as proof of anything, but as evidence that this is undeniably a system that is alive, moving, and worth watching more closely than it has been watched in years. What makes Teide different from the volcanoes that make global news for actually erupting is not the absence of activity. It is the presence of an extraordinary amount of preparation standing between that activity and any potential disaster. Few volcanoes on Earth sit beneath a monitoring network this dense, feeding data this granular, to scientists this transparent about both what they know and, just as importantly, what they do not. When Dominguez tells the public he cannot say whether this ends in an eruption, that admission is not a failure of science, it is science working exactly as it should, refusing to manufacture false certainty in either direction, refusing to tell 6 million annual visitors to the island either that everything is fine and always will be, or that catastrophe is imminent, when the honest answer sits somewhere in the vast, uncomfortable space between those two easy stories. So where does that leave the mountain now, in the summer of 2026, months on from the swarms that first pulled Teide back into headlines? The alert level remains unchanged, still at its lowest tier. The tremors have not stopped entirely, because volcanic systems this large essentially never go fully silent, but the intense clustering of February has eased into the kind of quieter, sporadic background signal scientists expect between active episodes. The instruments keep listening. The GPS stations keep measuring millimeters of shift in bedrock that has not moved meaningfully in over a century. The gas sensors near the summit keep sampling the air rising out of a mountain whose last confirmed eruption predates televised media, predates commercial aviation, predates almost every technology used to monitor it today. And somewhere beneath all of that instrumentation, 10, 12, 15 kilometers down, in rock nobody has ever seen and no camera will ever reach. Whatever process produced those 755 tremors in a single February night, that 90-minute signal never before recorded, those 2 centimeters of accumulated uplift continues at whatever pace it moves on, following a timeline that belongs entirely to the mountain itself, not to the instruments studying it, not to the scientists interpreting it, and certainly not to anyone standing at the cable car station taking a photograph of a peak that has, for now, kept whatever it is building to itself. The story of Mount Teide in 2026 is, in the end, not a story about an eruption that happened, because as of everything currently known and confirmed, no eruption occurred, no evacuation was ordered, no lava reached the surface. It is instead a rarer kind of story, one about the process that happens in the years, sometimes decades, before a decision like that is ever made by a volcano, the quiet accumulation of small signals that individually mean almost nothing and collectively mean that a mountain millions of people live beside, climb, photograph, and largely ignore, is not the frozen, permanent backdrop. It appears to be from a beach towel on the coast. It is a living system, on a scale of time almost impossible for a human mind to hold on to, one where 3 years counts as a short interval, where a century without eruption counts as a pause rather than an ending, and where the honest answer to the question everyone keeps asking, is Teide waking up, is the one scientists have given consistently throughout this entire episode. Not yet, as far as anyone can tell, but it is, without question, being watched more closely than it has been in a very long time, because on a mountain like this, closely is the only way anyone intends to be caught by surprise.